Hi, this is section 3.6 in your book, talking about what's called the leveling effect. The leveling effect. So this is a name for a simple phenomenon that is, I think, relatively easy to understand in the idea of chemical reactions. And basically what it says is that whatever base you have in a solution can only be as strong as the pKa of the conjugate of the solvent that you're using. So if you're using water and the base is strong enough to deprotonate water, then that means the strongest base that you will actually have in solution is the OH minus anion. And the reason why, to this kind of confusing little fact, is because there's so much water around in a solution. There's around 55 molar water. Sorry, I should make that neater. 55 molar, whereas normal concentrations of a base, say, could be, around 1 molar. This huge difference in concentration means that for every base molecule that's in solution, it is way more likely to come into close contact with a water molecule in the solution, which means that if it can, the base will end up deprotonating the solvent before it ever reaches the reaction. So you cannot have a more acidic, you can only reach the pKa or the base strength of the deprotonated solvent in this case. And the same thing actually goes for acids too. So if you have some acid, like let's say you put in a really strong acid, like this is a pretty strong acid, then it will likely deprotonate your solvent, or sorry, deprotonate. It will likely protonate the solvent if the solvent is more basic than your other reagents. Sorry, it's acting up here. And that is section 3.6.